So let's get started. Today we are going to look at chapter 7. The first section is about the data set. So throughout this chapter, we are going to look at some, things in statistics. We are not going in detail. So this is the short course in our, the Math 1001. Um, we will do all, briefly. Okay, so the first one. So look at the definitions given here. The frequency is the number of times a value in the data set. Okay, so you will be given some data sets, right? So data set is the numerical value which are given. Okay, so for example, or you may have any kind of values, right? So say I'm giving some numbers, data values, say 2, 5, 8, maybe 3 and maybe 6 and maybe one more 2 and maybe some 4s and so on, right? So so this is okay. So let me include one more, say 8. So this is an example of a data set, right? So how many data values are here? How many data values? The number of data values. Just count 1, 2, 3, 4, 5, 6, 7, 8, 9 data values, right?
9.
Okay. So the frequency means the data, you have to count how many times it occurs. The number of times each data occurs is the frequency for the particular data value, right? Um, if you want to make a table for these data values, so now my first column is always going to be the data values. So we denote this by X, and the frequency we denote by little f. This is frequency. So you have to, list all the data values, different values. So the smallest values to the highest. The smallest data value is 2. The next value I have 3. Then I have 4, 5, 6. I don't have 7, but I have 8, right? So like that, first you have to write all the different, the data values. Then here, the frequency means you have to count each data values occurs how many times. 2, how many 2s I have here? There are 2 of them, right? Therefore, the frequency for the data value 2 is 2. So what is the frequency of 3? 3 occurs only once, right? And the 4 occurs twice. And 5, once. 6, once. And 8, again, once. Oh no, 8, you have 2 8s, right? Okay, so now this kind of table, you are explaining everything in, the table 2 columns. This is called the frequency table. Okay? So, suppose if you add all the values along your frequency column, so we denote that by this notation. This is read as the sigma. This is actually a Greek letter sigma. The meaning of this is the sum of all f values. So that's the meaning of sigma f. So sigma f means you are simply adding all the f values, right? That means if I write like this here, the meaning is I am adding simply all the f values throughout that column. So simply you just add them. 2 plus 1, 3. 3 plus 2 is 5. 6, 7, 9. Right? So if you do correctly, the sigma f, the total along f should give you the total number of data values. Yes, I have 9 data values. Yes, I got 9 here as well. So it should match with your number of data values. Okay. So this is called the frequency table. So that's what this is. Okay. So now this is the guide you have. To construct a frequency table from the given data set, you need to follow this guide. So construct a two column table like I did here, right? And the first take as the data values, and the second one is frequency. Order the data from the least to the greatest in the left column. So in this column, you have to write the data values, in increasing order. Looking through the data set, determine how many times each value occurs and list them like this. So this is called the frequency table. Okay, so now let's move to the next one. The total number of data values is the sum of the frequency in the column. Oh, the term relative frequency. Relative frequency, right, is the ratio of the number of times a certain data values occurs to the total number of data values. Okay, what does mean by that? That means, suppose if I want to, okay, let me redraw this. So this is my data values, X. This is my frequency. Okay, for this particular example, I have 2, 3, 4, 5, 6, and 8. I had the frequency 2, 1, 2, 1, 1, 2. Now, the relative frequency, so let me write down here. How do you find the relative frequency? That is very simple. You first find the sigma f. We got that is 9. Now, the relative frequency means, so you take, suppose if you want to find the relative frequency for data value 2, let me take the corresponding frequency, then divide by the total value of your frequency, that is 9. Okay. For the relative frequency for 3, simply take the corresponding frequency 1, then divide by total, and so on. Okay. So if you do correctly, the summation of your relative frequency, just simply add these all fractions. Now I have fractions here. You should get always 1 if you do correctly, okay? So make sure that you are getting 1. 2 plus 1, 3 plus 2, 5, 6, 7. 7 plus 2 is 9. 9 over 9, which is 1. So you should get that correctly, okay? That is called the relative frequency. Right. So you could write the relative frequency in either decimal or fraction, either way. So if you want, even you could write in percentage form by multiplying 100 with this fraction. So that is there. Next term, cumulative relative frequency. What is the cumulative relative frequency? Let me construct one more column here. The cumulative relative frequency, okay, is simply, add the previous relative frequency with the current one. So you have to start always with the first one. Let me copy down here. Okay, so this is the cumulative frequency for the first one. For the second data point, 3, the cumulative frequency means what? You have to keep on adding with the previous one. Okay, so now here I have 1 over 9. Here I have 2 over 9. Add these two and put here 2 over 9 plus 1 over 9, which is 3 over 9, right? Now to find the cumulative relative frequency to the another one, add these two. So when you add those two, you will get 5 over 9 and keep on doing. The next one is 6 over 9. And next one is 7 over 9. And the last one is 9 over 9, which is 1. So if you do correctly, the last one should match with your total relative frequency number, which is 1. Okay? Now this is called the cumulative frequency. Next one, histogram. Histogram is a bar graph, but you should not have any, space or gaps between two blocks. Without space, you have to, draw the blocks. Now, my x value is always my data values. Okay. Your y-axis is always the frequency for each data. right? So now, if you look at this picture, what does mean by that? That means if you look at your first block, the first block says what? There are 5 data values, right, which fall from 6.5 to 7.5. There is only one data value which is, you know, falling in this range, and so on. So this is called the histogram. So now this problem says what? Given the histogram for a data set below, how many values in the data set are greater than 8.5 but less than 10.5? So we are basically counting how many data values are there between 8.5 to 10.5. 8.5 is here, 10.5 is here, right? Now with this range, you have to count how many data values. The number of data values is in frequency column. So if you look at from here to here, there are 2 blocks, right? So find the corresponding frequency for each block. For the first block, my frequency is 3. This is 3, right? For my second block, the frequency is 2. That means what? There are 3 data values from 8.5 to 9.5, and there are 2 data values from 9.5 to 10.5. And altogether, you have 3 plus 2. There are 5 data values from 8.5 to 10.5. That makes sense? Okay. So now this is one example. Okay. So make sure that you understand this. You are given the data set here. How many data values are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 data values given, right? So you are asked to make the frequency table. Remember, you need to arrange in order. So 2, 3, 5, 7, 10, 12, 13, and 18 different values. You are counting each value occurs how many times. So 2 occurs 3 times, 3 once, and so on, right? So if you want, you could make the total here and check. So if you add all the frequency numbers, you should get 16. Are you getting 16? 3 plus 1, 4, 4 plus 4, 8, 8 plus 2, 10, 10 plus 3, 13, 14, 15, 16. Yes, I'm getting correctly 16 data values, right? Okay, that's nice. So the next one, the frequency table below shows the age of the students in the programming class. Complete the relative frequency. So you are given basically a frequency table, but you are asked to find the, the relative frequency column you need to fill out. So we don't know how to do. First of all, you need to find all the total among the frequency. That is sigma f. So sigma f is 25, right? That is the total number. So we are finding here one by one. The first relative frequency is 2 over total is 25. Next one 4 over 25, 6 over 25, 7 over 25, and so on. So you could write either in decimal or in fraction. It's up to you. Okay. So that is there. Okay, the next one. What's that? Next one. A group of students were surveyed about the number of pets they have. Their responses are summarized in the relative frequency table below. What is the missing relative frequency? Oh, this is the missing one, right? You need to figure out the missing one. How did you do that? Okay, that means I already mentioned here. Where's that? Here, I already mentioned when you add all the relative frequency answers, you should add up with, right, 1, no? So that is the property now we are going to check. So here you are given 1, the remaining all. So we don't know that, this one. So if you do not know, keep that value as x. I don't know. So I'm typically finding x answer, right? So let us add all the relative frequency values then. So the first one is 0.3. I'm going to add the second one with x. I don't know. The next one is 0.15. And the last one is 0.2. The relative frequency property says that when you add all the possible values, it should add up with 1. So now, typically we are finding unknown x, right? You know how to find. So simply add these all like terms and solve for x. So if you add these three, which is 0.65, right? This one, subtracting 0.65 both sides. Therefore, unknown x is 1 minus 0.65, which is a 0.35. Therefore, the missing data is 0.35. Okay? So this is the way to, find the midpoint, missed point, sorry. Okay, the next one. The data set is summarized in the frequency table here. Using the table, determine the number of values which are greater than or equals to 8. Give your answer as a single number. The question is typically they're asking, hey, how many data values are there which are, greater than or equals to 8? Oh, you have to include 8 also. So my answer is not correct. I did not include 8. You need to include 8 also, right? Therefore, you have to include this 4 also. I missed that 4 actually. So you have to add that 4 also. Okay? So answer should be 27. So that means what? That means there are 27 data values which are greater than or equal to 8. Okay. So this is very brief section, no? In chapter 7.1. Okay. So do you have any questions so far? Okay. So then let's move to next one. Oh, here now we are going to find some meshes for a data set. So the first measure of central tendency for the given data set is median. The median is one of the measures of the center of data set. Okay, so if you are given a data set, the median will be the middle point of the data set. Okay, so you will be given a data set, right? So this is the guide we are going to follow. How do you find the median, the central point of your data set? This is the way. First, sort the data values in numerical orders from the smallest to the highest. You rearrange the data values. Then count the number of values in the data set. You have to check how many data values are there. If the number of data values, right, is an odd number, then you will have only one middle. If you have even number of data values, then you will have two middle values. Then you have to find the average of those to find the median. So we will look at these two examples, then you will understand. Okay. So now find the median of each of the following data sets. So look at the first data set. You need to arrange in order first. The smallest one is 3. So take your pencil and strike off one by one. The smallest is 3. Next, yeah, we have 4, but I have 2 4s. Then I have 5. Then I have 7. Then I have 8, but there are 2. Then I have 9. Then I have 10. So like that, you have to arrange, no? After arranging now, check how many data values are there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 data values. Remember, this is an odd number. So you will have only one middle number. How do you find that middle number? You simply strike off from the both ends. And you will find one middle number, right? So that is going to be my median. Therefore, median is 7 for this problem. Okay, or you could find like this. I have 9 data values, right? So add 1 with that number, then divide by 2. So So 9 plus 1, 10 over 2, which is fifth. So that means you have to check the fifth data value. That is going to be my median. The fifth data value after arranging. So this is the arrangement I have. Fifth data value 1, 2, 3, 4, 5. Fifth is 8, 7. So that's going to be my um, median, right? This is another way. Okay. Now here again, do the same thing. So I have 11, then 15. So there are two 15s. Then I have 16. Then I have 17. Then I have 18, but there are two 18s. Then I have 19. Okay, 20. Again, two 20s. Then 22. Then what? 23. Make sure that you are striking off all the numbers. So you have to cover all the numbers. Yes. How many numbers are there? 1, 2, 3, 4, 5, 6, 7. Oh, this is 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, now I have 12 data values, which is an even number. Therefore, you will have two middle numbers. So if you strike off from the both ends, you see now I have two middle numbers. Therefore, the median is the average of those two. Average means you have to add them and divide by 2. Okay, so if you want to use the calculator, put the parentheses. 18 plus 18 over 2 is 18. Therefore, median for this problem is 18. Okay. Okay. Now let's move to the next one. That's one more measure we have here. That is called mean. The center of data set is a way of describing the location. The two main measures of the center of the data sets are median and mean. The mean is simply, mean means average. Simply you are finding an average of the data set. Okay, how do you find the average? Or we use actually mean. So here we mean by sample mean. Okay, so we use x bar for sample mean. That's a formula to find the mean. So that is summation x over m. Remember, summation x means what? Sum of all the data values. So sum of the data values. Then you need to divide by n. This n is the total number of data values, right? Number of data values. So add all the data values, then divide by number of data values, which is called the x bar, sample mean, average. Okay. So we read this as x bar. Okay. So that is very simple, finding mean. Add all the data values in the set, then divide the sum of the data values by the total number of data. So this is, if you want to write in formula, this is my x bar. That is summation of x over n. Now in this problem, my little n is 10. You have 10 data values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Therefore, my sample mean for this problem is 7.7. Okay, so that is sample mean. So we have one more mean that is called the population mean. What's the difference between population and sample? Okay, the population is kind of a very big data set. Okay, it's a very big data set. For example, say you are given 1,000 data values. Okay, so this is 1,000 data values. So now, how do you find the mean of these data values? That is called population mean. Okay, so we denote this guy by mu. This is pronounced like this mu. This is one Greek letter. So the finding population mean is simply add all the data values from your population, then divide by 1,000 for this example. So that is population mean. Sample means you are picking only few data values from your population. So very small subset of your population is called the sample. So for example, say I am picking 50 values among these 1,000, you could pick any 50. randomly, just choose 50. So that is called the sample. So the sample mean is simply we use X bar, that is simply add all the 50 values, right? The summation of all X over little n. Now in this case, n is so 50. There are 50 values. So again, typically we use the same formula, but it depends on the number of values and the data values, whatever you are having, right? These are the two different notions we have: population mean and sample mean. Okay, so roughly, commonly, if you are asked to find mean, they mean sample mean. Okay, so that's what this says. Sample mean X bar is the average of the value of your subset of an entire population. The population mean is mu is the average of the set's value in your population. Okay, so far we know how to find mean if you are given data set. Now here, this one guides you to find the mean when you have like this table, right? How do you find the mean if you are given a table, right? So let me explain that part here. You are given a table, right? My data values here. So let me copy down this problem: 2, 4, 7, 8, 10, and my frequencies are 5, 6, 3, 4, and 2. This guide says what? This guide says for each row in the table, multiply the data values, right, with its corresponding frequency. Simply multiply these two numbers, right? So let me write down that is fx. So I'm simply multiplying f values with corresponding x values. Simply multiply these two. So 2 times 5 is 10, 4 times 6 is 24, so 1 times 3 is 21, 8 times 4 is 32, and 10 times 2 is 20. Simply just add them. That's what this says. After that, add the values from your previous step together to find the total of all the data values. After that, what you want to do is, you have to find the total for these two columns, right? I'm using the symbol now. The summation f, simply add all the f values, how much it is, 11, 14, 18, 20. Now here I'm adding all my fx values. Simply add this number: 4 plus 1, 5, 5 plus 2 is 7, 3, 5, 8, 10, 107, right? Now then, how do you find the mean? The mean x bar is simply take your summation of fx answer, then divide this by the summation of f. So this is the formula we use for the mean. So I think you don't have that somewhere here. If you want, you can copy down this. So this is the formula we use for the mean. Right? For this problem, the summation of fx is now I got 107, and I'm going to divide by summation of f is now 20. So take your calculator and divide. 107 over 20 is 5.35. Therefore, mean answer for this problem is 5.35. So the answer here, given in short form. So actually, this is happening. So you could write down like this. Okay. So that's the way to find mean if you are given a frequency table. If you have any question, please let me know. Okay. So now let's move to the next one. When dealing with the group data intervals, we are able to estimate the mean. Okay, this all we found the exact mean because we know all the exact data values here given. So then we could find the exact mean. But there are some cases we cannot find the exact mean. What is that situation? Instead of frequency table, you may have grouped frequency table, right? So you may have a table like this. Um, instead of data values, here you have now group, right? For example, I'm telling you, hey, there are three data values which is from 2 to 4. We don't know exact value. Any number may be 2 to 4, but there are three of them. The next one I'm telling you, 5 to 7. Say there are two of them. Say 8 to say what's next number 10. Say you have five of them, and the last one, say 11 to 13. Say you have six of them, right? Now look at the first column. I don't know exact data value. Only I know the range, right? In this case, I cannot find the exact value. Instead, we estimate, right? So how do you estimate? This guide says that. What do you want to do? If you want to estimate, you have to find what? The midpoints. You need to find the midpoints for each group. So our midpoint, we denote midpoint by x of m, the data values for the midpoints. So what you want to do is take your group, take the first group, and if you want to find the midpoint, simply add those two values, 2 and 4, then divide by 2. I'm finding the average of these two values, basically. So 2 plus 4 is 6, 6 over 2 is 3. This is my xm. The second one, my average is 5 plus 7 over 2. So that is 12 over 2 is 6. The next one, 8 plus 10 over 2, that is 9. The last one, 11 plus 13 over 2, that is 24 over 2, which is 13. Like that, you have to find your xm's, right? Now you have to consider all your xm's as your data values. Now problem is like here, right? Now you know your x values. You have to treat these all your x values. Now you have to do what? You have to multiply like here we did. You have to multiply now f and xm. So that is f times xm. Simply multiply this number with the number you got with xm. 3 times 3 is 9. Then here 2 times 6 is 12. 5 times 9, which is 45. And 6 times 13, which is 78, right? So like that, so simply multiply them out. And now, like this, you find the summation of, summation of f times xm now. Now find the summation of f. So if you look at this, what is my summation f here? 3 plus 2 is 5, 5 plus 5 is 10, 10 plus 6 is 12, 10 plus 6 is 16. And here, what is my summation of f times xm? Simply add this. 11, 16 plus 8 is 24, 2 remaining, 3, 7, 7 plus 7, 14, 144, right? Okay, now what is my estimated mean? Now you are getting estimated mean. Okay, simply I'm using again x bar. Formula says that is f times xm now, divide by summation of f. So that is 144 divided by 16. What is that? 144 divided by 16.
9.
Say it again.
9.
Oh, exactly 9. You're good. So it's 9. So that is there. So that is the estimated mean for this problem. Okay. Do you have any questions?
Not yet.
Okay, very good. Now let's move to the last measure for the data set, which is called mod. Mod is the number or numbers that occurs, the most of the data set. Which number occurring more, which is going to be your mod. You may have one mod for the data set. You may have several mods, or you may have nothing. There are three scenarios. Okay, so let me explain. Okay, the first one. Look at this data set. 2, 2, 5, 5, 5, 3, 3. Okay, I'm asking, hey, what is the mod for this problem? Which number occurs most? 5. 5 occurring 3 times, right? Therefore, mod is 5. Which number occurs more? You have to write the answer from your data set. Okay. Let's see who's telling answer for this. Suppose if I have a data set like this, now what is my mode?
It's still gonna be
Two
five.
and five.
2 and 5. Very good. Now you have two modes. 2 and 5 occurs twice. Both of them have same chances. So now you have several modes. Two modes, of course. 2 and 5. Okay? But look at this example. 3, 7, 9, 8. What is the mode?
Zero.
0. Your answer is correct. 0 means uh, we don't write 0, but you have to tell me that there's no mode. Okay. Definition says that there should be one number at least that should appear more times than the other data values. But here you cannot compare all, have the same number of frequencies. There's no data value which is not having higher frequency than the other. Therefore, if you have all same frequency in your data set, that means there's no mode. So you are right, not 0, but you are right, there is no mode. Okay, the last one, 3 3, 5 5, and 8 8. Then what is your mode?
3, 5, and 8.
Listen carefully. I said what? You should not have same frequency if you want to find a mode. All three numbers have now same frequency, right?
That'd be the same as the one before. There's no mode then.
No mode. Yes, here we go. So if you have same frequency, at least there should be one number compared to others should have more frequency than the other. But in this case, I don't have all two. Therefore, here also there's no mode. Okay. So these are the scenarios, no? Okay, finding mode. But now this should be super easy for you. Why don't you try? Check whether you are getting these two as a mode, which number occurs more. Check. Okay. Let's move to a 5-number summary. Right? Okay, what is meant by a 5-number summary? So if you are given a data set, always it is possible to find the 5 numbers. What are those numbers? We call that as min, Q1, Q2, Q3, and max. Suppose if you are given a data set, finding minimum and maximum is not hard. We know how to find the smallest and highest value among the data values. But look at these three guys. Any idea? You see the letter Q's everywhere, right? Q1, Q2, Q3. These are called quartiles. Quartiles. So Q1 is first quartile, Q2 is second quartile, and Q3 is my third quartile. What does it mean by that? That means, suppose, say, you are given some data values, right? Say this is my smallest data value. I am arranging in order first. So this is my highest data value, right? Now, if you have like this data values, so the middle one, the center one is going to be what? Just now we saw, right? Median,
Yeah,
right?
median.
Median will divide entire data set into two equal pieces, right? What will happen if I divide four equal pieces? So this is 25% of my data values will be here. Next 25 will be here, and third 25 is here, and the fourth 25 is here. That is why it is called the quartiles. Quartiles will divide the entire data set into four equal pieces. The first 25% covering the data set, which is called Q1. The second 25, that is covering 50% of your data, is called my median. Median is called as Q2, right? Then this point, Q3, will cover how many percentage from the beginning? It is covering 325, right?
75%.
75%, yes. That is my Q3. So these are the three numbers now we are going to find out. Okay, Q1, Q2, and Q3. Q3 is super easy, no? That is median, of course. Then we will see how to find them Q1 and Q3. Okay, if you look at Q1, Q1 is Q1 is nothing but the middle point of this piece, right? My Q3 is the middle point of this piece. Okay, the first half, you see, this is exactly a half piece of your data set. The first half is called the lower half of your data set. The next half is going to be my upper half of the data set. Okay, Q1 is simply the middle point of my lower half, right? Therefore, Q1 is nothing but my median of lower half. Q3 is going to be again the center point of my second piece, upper half. So again, it is also a median of my upper half. So find out these two by using your median techniques again. Then we will find out Q1 and Q3. Once you have Q1 and Q3, summarize everything. That's going to be your 5-number summary. So I will explain. Okay, so let us do this problem. Okay, so one of you have to tell me. I'm going to write down here. Could you tell me the numbers here? Could you tell me 23? What is next?
18,
Okay, go ahead.
19, 25, 30, 15, 26, 29, 17, 22, 33, 28, and 36.
Very good. So how many data points are given? Is it 13 of them?
Yes, 13.
Yes.
So that means you are given 13 data values. Now what is the question? Finding 5 numbers. Okay. What is your first procedure? First step is to rearrange your data values. So let us write down, ascending order. So which one is the smallest one? The 15?
15,
Yeah. The next one. Step 17 is the next one.
18,
18. Only one 18, right? Okay.
yes, and the 19,
22, right?
yes,
23, 25,
23, 25, 26,
26, 28,
28, 29,
29,
and the last
36,
one. Oh, 33 is there. Oh, 30 is there.
33, 30, 33, 36.
Make sure that you are covering all the numbers. Did I cut all the numbers? Yes, I strike off all. Okay, very good. So we have rearranged, no? Okay, now what is my task? Finding all 5 numbers, okay? So let me change my... Okay, so finding minimum is not harder. This is my minimum, smallest value. This is my max. Okay, let's see who is telling. Where's the middle number? You remember I have 13, right? 13 is an odd number. Add one more, 13 plus 1, which is 14. 14 over 2, which is 7. 7th place is going to be your Q2, median. 1, 2, 3, 4, 5, 6, 7. This is my median. right? That is my Q2, no? So that means what? That means this guy, median, is going to divide the entire data set into equal to pieces. This is going to be my lower half. This is going to be my upper half of the data values, right? Now, what is the procedure? Treat this data set as a separate problem and find the median of this data set and find the median of data set this side as well. Okay, so let's find those two then. So I'm using different colors. Okay, so now I'm going to find the median of my first half or lower half. How many data values here I have? 1, 2, 3, 4, 5, 6. Even. So you will have two numbers. Now I'm going to find the middle number. So the median of these two is going to be my Q1, that is 18 plus 19 average, right? Over 2. That is 18.5. That is my Q1. Now move to this side. Again, here also I will have a two midpoints. So my Q3 is going to be 29 plus 30 over 2. That is 59 over 2. That should be 29.5. That's it. You have all five numbers. After that, write it down. Min is 15. Q1 is 18.5. Q2, of course, median. That is 25. And Q3 is what? 29.5. And what? And the last one, max.
36.
36. But the good thing is you could use the calculator to summarize this five number. I'm going to show you how to, use the calculator to summarize all five numbers, okay? So let me write down the steps we follow, right, when you use the calculator. So, okay, so I'm going to use my calculator, right? TA83 plus. So go to stats, go to edit. We all know, right? So we did the regression problems in chapter 3 or 2, I believe. So now enter all the data values into your first column, L1 column, right? So enter all the data values. Okay, so that means I'm going to enter all the data values. So let me clear all the things and we have stats. So go to stats, edit, already number 1. So I'm going to clear my all the values. So I'm clearing all. Okay, so I'm going to enter my data values into L1 column, right? So order is doesn't matter. You could write either increasing or whatever you want. I don't want actually order. So I'm typing like a given order: 23, 18, 19, 25, 30, 15. What is that? 26, 29, 26, 29, 17, 22, 33, and 28. Oh, one more, 36. So I will have 13 numbers. Yes, I got 13 numbers, right? After entering all, now go to, if you want to quit again, or again, go to stats, second time, go to stats. Now go to one var stat. Do you see this option in your calculator? Oh, I think you have to go for a calculation, then one var test. Okay, let me check. So I'm going again to stats, calc now. Okay, you see number 1, one var stats. Number 1, right? Enter that. One more time. Oh, you see now, you get a lot of things, right? You get X bar also there, right? You see X bar? The first one, what is this X bar means? The mean, average, right? If you move your cursor down, you see now minimum 15, we got that, right? Q1, 18.5, we got that. Median, 25. Q3 29.5, and the max 36. Do you see all 5 numbers? Say yes or no?
Yes.
Yes. So this is the way to find the 5 number summary. Anyway, you are going to use calculator for the final, so it's very, very effective when you know how to use the calculator, right? Rather than doing manual. Anyway, now we have 2 methods to find out all 5 numbers. Does that make sense?
Yes.
Okay. That is there. Very good. So that is about all 5 numbers. Now, the last point I have to tell in this section is drawing box plot, right? So far, we summarized all by number wise. Now we are going to draw a nice picture to check how our data values distributed, right? Picture wise, we are going to draw a picture showing everything under the picture, all 5 numbers, right? That picture is called the box plot. So box plot is basically will have like box, right? With like this. So the smallest value will be here, minimum. Then this line is my Q1. This line is my Q2. The third line is Q3. And the last one is max. So this kind of picture will give you some idea of what kind of distribution you have. So this is called box whisker plot or box plot. So if you are asked to draw box plot, now we are going to learn how to draw. Now you know, right? After finding all 5 numbers, let me explain manually how to draw this picture, right? This is the way. First, draw a real line, right? All the 5 numbers, mark all 5 numbers in this real line. So let me call this is my 0 value. What are the values I got here? I got minimum is 15, right? So say 15 is somewhere here. Then I got my scale is not good. Okay, doesn't matter. I'm just explaining. So the next one I got 18.5, then 25, right? So you have to write into the scale. So my scale is not correct, right? So make sure that you are making correct scale. So let me erase this and so, so I'm taking now 15 somewhere here. So this is 15 scales. Then I need 18.5 will be very close. The next number is 25, right? So 25 a little bit further. Then I need 29.5, little bit bigger than that. And the last one is 36 is mark all 5 values. Now draw this shape. So draw somewhere here, okay? So now first you have to draw the box. Draw the box with Q1, Q2, Q3. My Q1 is, this is my Q1. This is Q2. This is Q3. I'm drawing the box somewhere here, right? So my Q2 is now here, and my minimum point is here, and my maximum point is here, and join this. So this is the box plot for the given data set. Okay, very easy. Okay, so this is the box plot. So in your box plot, you have to, or you have to tell correctly all the values. Okay, so if you want, you can write down here. This is your minimum. So this is your Q1, Q2, Q3, and this is max. So you have to, put all the values. Otherwise, we don't know, right? So this is the box plot. But again, you could use the calculator also to draw the box plot. First, enter all the data, right? So first to feed all the data, so enter data values into L1. Okay. Then go to step plot. choose box plot. Okay, then you need to set your window. Make sure that window is covering all the values. Okay, I will explain. So then after that you need to just draw. Okay, so I will show you now. We already have entered all the data values for this problem. Okay, we have already entered all the data values. Now I'm going to set the window. So go to the window. Remember, um, you see this value, this real line is my x value. This height is now y value now. So you have to plug in the correct the range. So my x minimum value, you see the minimum value of the given data is 15. You could start with 15 there or whatever, maybe I am starting with say 10. You could start if you want 15 as well, but I need to show your picture in the window. So the maximum we got 36, but let me check maximum as a 40. Scale leave 5, minimum say 0, say maximum 1. So this is you could keep 0 and 1 if you want 0 2. So that's it. So this is my set. Then come out from this window. Now go to the second button and set plot. Okay, second button and white, that is set plot. You see here I'm choosing plot number 1. Make sure that remaining all off. So I'm choosing number 1, enter. Right, I'm under number 1. Which type of graph I want? I want box plot. So move the cursor into the box plot number 4. I need a number 4. Okay, so then enter. Then it will ask you, hey, which value you data you put. I have put the data into L1 column. If you put L2, make sure that you are changing there. But I already have entered all the data into L1. I'm good. Keep the frequency as 1. Okay, so this is the setup. That's it. Oops. That's one. Okay. Let me just change. Oh, what's happening? Okay, so now come out. Let's see, graph it. So now you got box plot, right? So similar to my graph, whatever I have drawn here. But you don't see any number here. If you want to check the numbers, you have to press the trace button here. You see the trace? Click that. It will give you, all the values. That point is median. So if you move your cursor to the left or right, you will get the corresponding, So if you are asked to draw a box plot, you could use calculator and copy down your picture and put the correct values, that. Does that make sense?